Okay, so welcome to today's lesson. We are just going to simply introduce organic chemistry and what it is about. Okay, so you can see from the objectives there, we are saying we're going to define what organic chemistry is. Okay, and then we are going to discuss why these organic compounds, okay, are called um, carbon compounds, or compounds of what? Carbon. Okay, and then we are also going to discuss why carbon is so special. Okay, why carbon is so special when we talk about organic chemistry. Okay, and then uh, there is a property that carbon has, which is called as catenation. Okay, so we are going to discuss where does carbon get the catenation ability. Okay, and then to end the class, we are going to discuss the origins of what these carbon compounds. Okay, all right, so the first thing there is to define what organic chemistry is. Okay, so by definition, we say that organic chemistry is just the study, okay, of carbon and its compound. Okay, so it's the study of carbon. Let me write that properly. Okay, it's the study of carbon and its compound. Okay, so these compounds have to be made of what? Of carbon. No wonder we are saying it's the study of carbon and its compound. Okay, and then from there we can discuss the second point there, where we said why are we calling these compounds carbon compounds? Okay, why are we calling these organic compounds compounds of carbon or carbon compounds? Okay, so the reason is simple. Okay, the reason is that carbon is actually, okay, carbon is actually the chief, okay, carbon is actually the chief, or we can say it's the main element. Okay, it's the main element of all organic compounds. So of all organic compound, I'm just going to write OC there. Okay, so if a certain compound does not have carbon, okay, then it can never be an organic what? Compound. Okay, so this carbon here is the chief or main element of all organic compounds. Okay, no wonder it's very what? Important. Okay, so if no carbon is present in a compound, okay, then we say that the compound is not organic. Instead, it will be what? Inorganic. So for example, water. This water here is not organic because we see that we do not have any what? Any carbon there. Okay, and then we also have some exceptions of compounds that have carbon but are not organic compounds. So for example, carbon dioxide, okay, or carbon monoxide, okay, or let me say carbonate. Okay, let me say carbonate like this. How do I write carbonate now? Forgotten how to write carbonate. Okay, I'll just give those two examples there. So if I have carbon dioxide and carbon monoxide here, we see that these compounds contain carbon quite alright, okay, but they are not organic compounds. So these are exceptions. Okay, so for a compound to be called an organic compound, it has to have what? Carbon. So for example, let's give an example here of a carbon compound. Okay, so example, if we write methane, so methane, we're just going to write this symbol here. So we see that this one has carbon and then it has 4 hydrogens here. So this compound here is a compound of what? Carbon. Okay, so this carbon here will be the spinal cord. Okay, it will be the spinal cord of all organic compounds. So spinal cord of all organic compound. Meaning what? Okay, meaning that it's like the backbone. Okay, it's the backbone, or we can say it forms a carbon chain. Okay, so we have some organic compounds that have carbon bonded to carbon, carbon bonded to carbon, just like that. Okay, so in these organic compounds, we are always going to find a carbon chain, okay, and we are going to refer to that carbon chain as the backbone of the molecule. Okay, so after we define carbon as the chief element of organic compounds, we can talk about the hydrogen. Okay, so this hydrogen here is the second. Okay, so carbon is the second chief element of carbon what compound. So second chief element of carbon compound. Okay, so most of these um, organic molecules, okay, they are going to contain first of all the carbon, and then the second uh, atom they will contain is the hydrogen. Okay, so we say that the hydrogen is the second chief element. Okay, and then when you have a compound that contains only carbon and hydrogen, we call that compound as a hydrocarbon. Okay, hydrocarbon. So the hydro comes from the fact that it has hydrogen, okay, and then the carbon comes from the word carbon itself. So you form a hydrocarbon. So when you talk about hydrocarbons, they'll just be those compounds that have carbon and hydrogen alone. Okay, so let's give examples here. Okay, let's give examples. So the first example that I'm going to give is butane. Okay, so butane has this formula. Okay, I have C, another C bonded to another C, and then another C. Okay, so this C here will be bonded to H, even this one H, this one H, that one H. Okay, and then this one here it will have 3 hydrogens like that. So this compound here, okay, we can see that it's made up of only hydrogen and what? Carbon. So it's a very good example of a hydrocarbon. Okay, so the name of this is called butane. So as we go on this course, we are going to learn how to name these compounds. Okay, it's very easy. We just have to follow some simple steps. Okay, and then these organic compounds, okay, some of them contain other elements. Okay, so examples of other elements that these organic compounds can contain include nitrogen. Okay, they can contain oxygen, they can contain phosphorus, they can contain sulfur, and then they can contain halogens. Okay, so know that halogens are found in group 8 of the periodic table. So for example, we have fluorine, they contain chlorine. Okay, we have bromine. Okay, we also have iodide like that. Okay, so they can contain first of all the carbon, the hydrogen, and then in addition to that we can also find the nitrogen, oxygen, phosphorus, sulfur, and all these halogens that we can see here. Okay, so that brings us to point 3. Okay, that brings us to point 3, where we are answering the question, why is carbon so special? Okay, so why is carbon so special? Okay, so the answer to this question, okay, may come from the position of carbon on the periodic table. Okay, so when we go on the periodic table here, it's just I don't have a sample here. So when you go on the periodic table, you are going to have the first group here, okay, and then you are going to have the second group, and then here somewhere you are going to have those transition metals, okay, and then you are going to have the third group, and then once you have this third group, the fourth group, that's where you're going to find your what? Your carbon. So in this fourth group here, you're going to find your carbon, and then after that we are going to have 4 groups again there. Okay, so I'm going to write like this. We're going to have 1, 2, 3, 4 groups there. Okay, so of these groups that are on the left and right of the carbon, so carbon will be found in here, the red one. Okay, so these 1, 2, 3 groups will be groups for metals. Okay, and then the immediate 3 after the group where the carbon is, they will be what? Non-metals. Okay, and then the last group here is just the group for these halogens here. Okay, so from its position on the periodic table, we can tell that carbon is so special because on the left hand side we have 3 groups of metals, and then on the right hand side we also have 3 groups of what? Non-metals. Okay, so what does that mean? Okay, so carbon is in group 4, and remember what we learned in our first semester. Okay, if an element is in group 4, then it means its valence is what? 4. Okay, that's what we learned. We learned its valence will just be what? 4. So what does this valence 4 mean? Okay, it means that those elements, okay, specifically the carbon, for it to be stable, okay, it has to make 4 bonds. Okay, this carbon, for it to be stable, it has to make 4 bonds. So we can have carbon here, and then it will be bonded to another element, bonded to another element, bonded to another element, bonded to another element. Okay, so in the structures of organic compounds that we are going to be drawing, this will be our primary goal. Okay, to make sure that this carbon is always bonded to 4 elements. Okay, so these 4 bonds can come in multiple bonds. For example, I can have carbon and then it's bonded, double bonded to 2 atoms like that, or I can have carbon which is triple bonded, and then that side it's 1. Okay, so the main goal is to make sure that this carbon has 4 bonds. Okay, so the carbon, since it's in group 4, it has a valence of 4, and it means it can make a maximum of what? 4 bonds. Okay, it can make a maximum of 4 bonds. Okay, so we can say since it can make these 4 bonds, okay, by using its exceptional ability, okay, it can combine with itself. Okay, it can combine with itself many times. Okay, so you can have carbon being linked to carbon, carbon being linked to carbon, and then you form a long chain of what? These carbon atoms. Okay, so this attribute of carbon bonding to itself over and over again is what we are referring to as, okay, let me clean this part, is what we are referring to as catenation. Okay, so we're going to say catenation like that. So this catenation here is simply the ability of carbon to bond to itself continuously to form very long chains of what? Compounds. Okay, so catenation makes this carbon atom, okay, to be very special because it can bond to itself a lot of times. So for example, let's pick any other element from the periodic table. Maybe I pick sodium. Okay, sodium can never bond to itself. Okay, so it can never bond to itself. What about I pick potassium? Potassium can never bond to itself. Okay, this can never happen. All right, maybe I say chlorine. Okay, chlorine can bond to itself, but it can only bond to itself once. Okay, and that's all. You never see chlorine and then chlorine again, chlorine like that. No, this one does not exist. Okay, but for this carbon, it has this special ability which we are calling catenation. Okay, where it will be able to be bonded to itself continuously, okay, to form very long chains of organic what? Molecules. So that's why the carbon atom is very special. Okay, so from this property, okay, it will move from forming simple molecules like this methane here that has just 1 carbon, okay, to very complex molecules. And these complex molecules, we are going to find them for example in DNA. Okay, so that DNA that is in our body, it contains millions and millions of what? Carbon atoms. Okay, so no wonder carbon is special because of this ability catenation, where it's able to bond to itself continuously. Okay, so now where does this carbon get this ability, okay, to bond to itself continuously without stop? Okay, so where does it get the catenation ability? Okay, so let's talk about that now. So let me just clean this up. Okay, so this catenation here, where does it come from? Okay, where does that catenation come from? Okay, so catenation comes from the fact that the carbon atom, okay, can be excited. Okay, so carbon atom, how many electrons does it have? Okay, so carbon, we know that it has 6 electrons, right? So when you write the electronic configuration of this, we say it is 2 and then 4, if we write it in this form. Okay, and then when we write it in the form where we are considering the orbitals, remember what you learned in atomic structure. Okay, we said it will have about 3 orbitals here. You have the 1s orbital, okay, and then you have the 2s orbital, and then you have the 2p orbital. Okay, so we know that in the s orbital we will have 2 electrons. Even this one here will have 2 electrons. So we have 2 plus 2, which is 4. Okay, and then we're supposed to have is it 6? Yeah, so we're supposed to have 6. So it means the other 2 will be in the what? The 2p. That's what it means, right? Okay, so from these orbitals here, the state of the electrons in these orbitals will change depending on the state of the carbon atom. Okay, so we have the ground state carbon. Okay, so carbon in its ground state, okay, we have the following arrangement of the electrons in these orbitals. Okay, so we have the first orbital here, which is the 1s, and then the second orbital, which is the 2s, and then now we have that third orbital that has 3 suborbitals like that. Okay, so this here is the 2p orbital. So now when we are arranging these electrons in these orbitals, okay, we arrange them in this order. Okay, so in the 1s we have 2, in the 2s we have 2, and then in the 2p we have 2. So how do we arrange these 2? We are going to say 1 there, and then we put another one there. Okay, so in this state where we are seeing this carbon here, okay, it's in its what? Ground state, meaning it's not excited. Okay, so what happens when this carbon is excited? So I'm going to write excited state here. So excited state of carbon. Okay, so when this carbon is excited, it means there will be a movement of some of these electrons. Okay, there will be a movement some of these electrons. So what will happen is that the 1s will be intact, will still have its electrons like that. Okay, and then this 2s here, okay, when this carbon is excited, something is going to happen to the 2s. So let me first write it the way it is, like this. This is the 2p, and then we have one electron there. So in this state, which is the ground state, okay, the carbon atom is not that stable because we have this suborbital in the p orbital that is empty. Okay, so when it's in the excited state, what is going to happen is that the electrons from the 2s orbital will gain energy. Okay, so once they gain energy, they'll move. Okay, so one of these electrons will move and it will go to that suborbital like that. Okay, so what we end up having is, okay, I have the 1s here which is intact, and then this 2s, okay, this 2s here is just going to now have 1 electron. Okay, and then here you're going to have these 3 suborbitals for p having 1, 1, Okay, and then we have this one that came from the 2s orbital there. Okay, so this carbon now has been excited, okay, and one electron has moved from the 2s orbital to the 2p orbital. Okay, so what is formed here now is what we call as the hybridized orbital. Okay, so the orbitals that will form here will be the new orbitals, okay, and we'll give them a name, 2sp, and then we are going to write 3. Okay, 2sp3 orbitals. Okay, so those are the orbitals that are going to be made. So what does that mean? It means we have one s orbital, which is this one, and then for the p we have 1 2 3. No wonder we're writing p3 orbitals there. Okay, so when this carbon, okay, is excited, it attains this form that I've shown you here, and then this form here is very, very stable. Okay, so with that stable form, it's going to form bonds with other elements. So let me just write the hybridized orbitals. So we have 2s, okay, and then this 2s has combined with the 2p. Okay, so we have now formed the 2 sp orbitals, like 2 sp3. So 2 sp3 orbitals, which have one electron in each of them, like that. Okay, so it means they have a space where another electron can come here, like that, like that, like that. Okay, so because of that excitation of the orbitals, okay, it will bond to four other elements. Okay, so one element can come and it will bond here, another element can come and bond here, another element can come and bond there, another element can come and bond there. So that's why we are saying that carbon can form 4 bonds like that. Okay, so it's because of this excitation that it undergoes and this hybridization that it forms. Okay, so that's where the ability for carbon to combine to itself endlessly, okay, comes from its excited what state. Okay, so any questions there on what I've explained? Any questions there? Okay, no questions. All right, so that's where the power for this carbon to form bond endlessly with itself and other elements comes from. Okay, from its excited what form. Okay, so I've explained that, and then the last thing that I'm going to explain today is the origin. Okay, I'm going to explain the origin of these organic compounds. Okay, so it is believed to these organic compounds, they are believed to come from animal, okay, animal and vegetables and vegetable origin. Okay, so when you go back in the past, okay, at some point these organic compounds were actually called um, animal derivatives or vegetable derivatives. Okay, so during the early stages of chemistry, okay, it was believed that the substances were composed of carbon and hydrogen, okay, with some uh, uh, little amount of nitrogen, oxygen, and phosphorus. Okay, and these were obtained from this animal and vegetable matter. Okay, so now it was in the early 19th century there. Okay, there was a discovery that was made. Okay, there was a discovery that was made while they were treating some animal fat. Okay, so what they discovered is that when you get this animal fat, okay, and then you react it with okay, then you react it with sodium hydroxide. Okay, this sodium hydroxide has to be dissolved in water. Okay, what you're going to get here is just a soap plus, okay, you're going to get a soap plus glycerin, okay, or glycerin. Okay, so this here was what was believed. So from this animal fat here, okay, if you want you can put the vegetable fat here, and then you react it with sodium hydroxide. Okay, it was believed that you are going to get what? Soap and um, glycerin here. Okay, and then when you get this soap that you formed here, okay, and then you acidify it, meaning you add an acid to it, you are going to form fatty acid. So you get this soap and then you add an acid, you are going to get what? A fatty acid. Okay, so these here were the origins of um, these carbon compounds. Okay, so some other theories, they will talk about uh, they will talk about maybe the synthesis of urea. Okay, which before then was commonly isolated from human urine. Okay, but we are able to synthesize this urea in in a laboratory. Okay, so that's how they can make this urea that they put in fertilizers and the like. Okay, so this here is a brief history about these organic compounds. Okay, so any questions there? Okay, if there are no questions, then this was an introduction to organic chemistry. So when we have another class, we are going to talk about bonding. Okay, we are going to talk about the types of bonding. Maybe before we do that, we are going to talk about the properties, okay, of these organic compounds. We know the properties of organic compounds, and then we can go into the bonding. Okay, and then after we do the bonding, we can go into the different types of organic compounds. So we have alkanes, we have alkynes, we have alkynes, okay, we have alkaloids. All those things we are going to what? We are going to talk about them. Okay, so uh, this is where I end, unless there are any other questions. Okay, so if there are no questions, then have a blessed night. The classes will continue tomorrow.